So today a quick we'll talk about density. Density is mass divided by volume. Density is what you think about when you think about a pound of, say, lead versus a pound of feathers. A pound of feathers takes up a lot more space, a lot more volume for the same mass, so it has a small density. On the other hand, a pound of lead takes up very little volume for that same pound. It has a large density. So when we think about heaviness, we're really thinking about density. Okay, density can have a variety of units depending on the state of matter you're looking at. The SI unit for density is kilograms per cubic meter, which is way too big for anything we're going to be using. So with solids, we're going to be using density in grams per cubic centimeter. For liquids, we'll be using density in grams per milliliter. People just frequently flip these back and forth and talk about solids as grams per milliliter and liquids as grams per cubic centimeter, but it makes a little more sense this way. For gases, they are in grams per liter because gases are so much less dense than liquids and solids. Wow, yeah, okay. A cubic centimeter is just a cube, 1 centimeter on a side. It's about the size of a half pair of dice, right? Pair of dice, one die. So if you look at this equation, D equals M over V, you can rearrange this to either, you can solve for density or you can rearrange it to solve for mass, where you get volume times density equals mass. All I did was multiply both sides times the volume. Or if you're given density and mass, you can be asked to solve for volume. So isolating volume, you get volume equals mass divided by density. If you're not good at rearranging, keep these three someplace in your notes. Put a little box around them. Okay, so let's do a simple one. And then more one like you're going to be doing on your lab. Okay, so we have a sample of liquid. Has a mass of 10.3 grams and its volume, same sample, is 8.7 milliliters. What's the density? Okay, very, very straightforward. Okay, you have mass, you have volume, you divide. So D equals M over V equals 10.3 grams over 8.7 milliliters. And during the division to the proper number of significant figures, which is in fact 2, you end up with 1.2 grams per milliliter. Easy peasy, as they say. Okay, so let's try another one. In this case, we have a marble. Okay, so that would be example A. Here's example B. We have a marble. It has a mass of 18 grams and a density of 6.3 grams per milliliter. What am I looking for? Obviously the volume. I've got 2, I need to solve for the third. So my volume is equal to mass divided by density. I probably should have used a big D over here. I'm looking at the units. I have 18 grams, 18.0 grams. Divided by 6.3 grams per milliliter. The grams will cancel. I have 1 over milliliters, which is going to give me milliliters on the top. And that is 2.9 milliliters for the volume. Okay, the last example, and the reason I'm actually writing this all down and not just doing it live, it pertains to your lab. You have a sample of a metal. And this sample of metal has a mass of 25.4 grams. you're going to put the metal in a graduated cylinder. So you start, and a graduated cylinder has 20 milliliters of water in it. The graduated cylinder with the metal has a volume, has a water volume. Let's call it a water height, because this volume is not all water, of 26.8 milliliters. What's the volume, or excuse me, what's the density of the metal? Okay, so we've got a mass here. We have some information here that's going to allow you to calculate the volume. Now, we started with 20 milliliters of water. We put the piece of metal or the pieces of metal in, and the volume of the water rose up to 26.8 milliliters. The difference in these two volumes is the volume of water displaced by the metal. So if we want the metal, we take 26.8 milliliters. We subtract the initial volume. Okay, so it's final minus initial. And we get the volume of the metal as 6.8 milliliters. Okay, that's my volume as I write around the corner. So density is mass divided by volume. That's a V. It's not a funny looking K. The mass is given up here at the very top of the problem, 25.4 grams. The volume we had to calculate, it's 6.8 milliliters. This is called density by water displacement. It actually has a name. We divide these two. I'm going to switch the units on the density of the metal to grams. This is the volume of water. Or, yeah, grams per, what did I just do? I'm going to switch it to cubic centimeters, but doing the division, I get 3.7 grams per milliliter, but since it's a solid, let's call it 3.7 grams per centimeter cubed. Okay, that's how you find. When you have a problem like this, I would start by boxing every single number that you have. Okay, and looking at them very carefully and even labeling them like mass metal, V initial of water, V final of water, so you know exactly what you're doing. Volume of metal here. That will make life easier. Otherwise, you're going to take this mass, where is it? This mass and maybe divide by 20 or divide by 26 when you don't have to. So this is what you're going to be doing on your lab. Enough for density for today. Goodbye.